Let me introduce KOMPAS-3D. It's a CAD system created to solve engineering design tasks. For 37 years, we've been developing and continuously improving KOMPAS-3D along with our other products. Today, our team includes over 1,500 employees, with more than 600 dedicated specifically to research and development. We operate offices across Russia and the seas and collaborate with partners worldwide. Our customer base now exceeds 17,000 companies, ranging from small businesses with a single license to large corporations managing more than 1,000 licenses. A few more numbers about our flagship product and the main focus of this presentation, KOMPAS-3D, a powerful CAD system. Today, more than 12,000 corporate customers, from individual entrepreneurs to large corporations, use KOMPAS-3D with success. Over 3,300 educational institutions teach their students how to design using KOMPAS-3D. With 100,000 downloads per year, it's easy to see someone downloads KOMPAS-3D roughly every 5 minutes. This slide highlights the wide variety of industries where KOMPAS-3D is applied. All of the models shown here are real projects created by our clients. Since 2003, we've been organizing the annual 3D Modeling Expert Contest for professional users of KOMPAS-3D and its applications. The competition brings together both independent participants and corporate teams. You can explore the winning projects on the contest website. What's inside KOMPAS-3D? Let's take a closer look. The current release is version 24. KOMPAS-3D consists of base components and additional components. The base components are a system for part and assembly modeling in 3D space, a 2D editor for designing drawings and schemes, and a text editor. Additional components include various applications that allow you to solve specific tasks. Performance. High speed and productivity when working with large assemblies were the core concept of one of the previous versions of KOMPAS-3D. We continue to develop this idea, and each new version is faster than the last one. KOMPAS-3D provides working techniques and specialized tools for handling large assemblies, such as layout geometry or component load types. This slide highlights impressive large assemblies created by our customers. Next, let's talk about functionality, the largest topic. KOMPAS-3D supports several types of 3D modeling: solid modeling, surface modeling, sheet metal modeling, and object modeling. Solid modeling is the creation of a complete three-dimensional model that defines the full volume and physical properties of an object. Solid modeling usually begins with a sketch. Based on the sketch, we create basic 3D geometry, adding volume by extruding or revolving the sketches. Finally, we add elements such as fillets, holes, or ribs to complete the digital twin of the real product. Models can, of course, be parametric in KOMPAS-3D, as shown with this simple brick model. By changing parameter values, we get new bricks. In this way, one model can contain many variants of a part or assembly. I'm changing the number of holes here, and the model is immediately rebuilt. I'd also like to highlight some new features introduced in version 24. They may not be the most important additions, but they're certainly spectacular. One feature allows you to assign a range of values for certain matings. This means you can limit the movement of assembly parts to realistically imitate the working positions of a mechanism. Another feature lets you modify a component's shape according to its position in the assembly, without changing the original source file. The deform command enables you to edit certain operations of a component and save the result directly inside the assembly, while the source file remains unchanged. Here I am modifying the pipe shape to connect it with the other components of the fuel line. Sheet metal modeling is the creation of models of thin-walled parts made from sheet material with features such as bends, flanges, and the ability to generate a flat pattern for manufacturing. Using sheet metal modeling in KOMPAS-3D, you can design a wide range of parts such as housings for appliances and electrical devices, shelves, brackets, and much more. Essentially anything that can be produced from sheet metal through bending and stamping. And of course, you can generate a flat pattern of the part to prepare it for production. Surface modeling is the creation of a model using only the outer surfaces of an object without defining its internal volume. Surface modeling is most often used in aircraft manufacturing, shipbuilding, transport engineering, and in the design of consumer goods and technological equipment. Typically, surface modeling begins with a kind of frame composed of special curves and points. Based on this frame, surfaces are created. To convert surfaces into a solid, you can add thickness and assign a material. If the surfaces form a closed volume, you simply knit them together to obtain a solid. One of the most popular commands among our users is rounding surface. It creates a transition surface between two selected surfaces that cannot share a common edge. This command is constantly being improved, offering various settings to control the shape of the rounding surface. When discussing surface modeling in aerodynamics or hydrodynamics, we should also mention the built-in tools for visual analysis of surfaces and curves. On the slide, you can see the results of curvature checking displayed as a curvature plot and a color map. These tools allow you to find optimal geometry for a curve, identify areas of maximum curvature on a curve or surface, and check continuity types at curve junction points. Object modeling means using pre-made parts to create a product without relying on sketches. These objects can be modified quickly and easily, and they contain a lot of useful information designed to behave in specific ways. With applications, you can extend the possibilities of KOMPAS-3D. They allow you to add pre-drawn objects such as pipes, gears, fasteners, and other shapes directly into your 3D model. On this slide, several applications are shown. You can find more details about these and other KOMPAS-3D applications on the ASCON website. Reverse engineering is the act of dismantling an object to see how it works. There are a variety of reasons to do this. For example, reverse engineering helps recreate critical parts when original documentation is missing or the manufacturer no longer exists. An approach to reverse engineering using KOMPAS-3D consists of several steps. We'll begin with the ability to read different formats such as STL, JT, and OBJ. After importing such models, KOMPAS-3D converts them into polygonal objects. Polygonal objects are represented as triangular meshes. They describe the surfaces of 3D objects with high accuracy while requiring minimal computational resources. You can see one of these polygonal objects on the screen. The options for working with polygonal objects are limited. Polygonal objects cannot be edited and are not transferred to drawings. However, you can take measurements between vertices of the polygonal model and snap to the vertices while creating new geometry. What else can we do with the polygonal objects? The surface adjustment command allows you to generate parametric surfaces by approximating selected regions of a mesh model. The result of such an approximation is shown in the middle of the slide. Then you can connect the surfaces and transform them into a solid body. We're constantly improving the deviation analysis command, which allows comparison between two objects. For example, a part and its polygonal model displayed on the screen. You can adjust precision and deviation ranges, and the calculation will produce a color map as a result. KOMPAS-3D includes a functional 2D editor. It allows you to generate views from the model or create a drawing from scratch without using a 3D model at all. You can create either a parametric drawing or a draft without parametric constraints. When a drawing contains associative views generated from the assembly model, you can also generate a bill of materials and place it directly in the drawing. Also, I like to emphasize that the 2D editor is a standalone product and can be purchased separately. If you prefer to abandon drawings altogether, you can create a model-based definition model by adding product and manufacturing information directly to the 3D model. Usually, software developers use their own proprietary formats to save 3D models and design data. These formats are closed, and other CAD systems have very limited ability to read them. At present, there are no tools on the market that allow complete transfer of all data from one CAD system to another. In most cases, only geometrical data can be transferred. KOMPAS-3D allows you to work with such formats through special converters or by using universal data formats such as STEP or IGES. Working with imported geometry is one of our priority themes. We continue to develop data exchange tools and tools for direct editing of geometry without design history. KOMPAS-3D provides several scenarios for working with imported models. Let's take a look at some of them. One option is to insert a model in a proprietary format directly into an assembly. On this slide, I add a bracket model that was made in SolidWorks into the assembly. Kompas creates a kind of geometry representation of the model that remains linked to the source file. It's not possible to modify the model in Kompas, but if the source file is changed in the CAD system where it was created, the changes will be reflected in Kompas. The model elements can be used as a base for placing other components or creating new ones. Another way to work with imported models is to modify them using direct editing tools. These tools allow you to refine the model without design history. Here I delete the hole in this reducer housing model, which has no design history. Then I move the inspection window hole using direct modeling tools. A further scenario involves using a special application called 3D model recognition. This application enables you to recreate the design history of an imported model. The recreated history will not be identical to the original, since Kompas generates it according to its own logic. You can see how this process works on the current slide. To help users smoothly start working with KOMPAS-3D, several resources are provided. You can see them on the slide. The first four, along with the offline help system, are built into KOMPAS-3D. On the left, you can see the Academy page with free KOMPAS-3D courses. It's also possible to validate your KOMPAS-3D proficiency level and receive an official certificate. More details are available on the certification page. This service is free. You only need to register on the site. Another important direction of development for KOMPAS-3D is the version for Linux. Our team is working on it, and we expect the result in 2027. Finally, let me summarize the key points that demonstrate why KOMPAS-3D is an excellent solution for engineering challenges. KOMPAS-3D is a professional CAD system built on its own geometric kernel, which ensures performance, stability, and independence. It delivers high productivity when handling large assemblies and complex geometry, supporting solid surface, sheet metal, and object modeling. You can purchase a perpetual license at affordable prices, paying only for the components you need. A 30-day trial version allows you to explore the system, and its intuitive interface, together with free resources, makes it easy to start working effectively right away. These were the highlights I wanted to share with you. Thank you for your attention.